Hello, let's look at number 4. So it says, if the plane has friction so that the sphere rolls without slipping, what is the speed, VCM, of the center mass at the bottom of the inclined plane? So now it's going to roll, okay, which means I do have friction, which means it's going to be rolling. Remember, with these type of questions, I don't actually have to include the friction in my energy setup, because this is an energy question, just like number 3, because the rotation part, that takes care of the work done by friction. Okay, so I'll have my PE at the beginning, and that will equal to my KE plus my rotational KE rot. Okay, so I have mgh equals 1/2 mv squared. Now this v here is going to be the center of my velocity, the velocity of my center mass, plus 1/2 I omega squared. Okay, and then I need to plug in for omega because I don't want omega in my final answer, right? And so this will be mgh equals 1/2 mv squared plus 1/2. Now they say I is just I, so I have to leave it there. I can't do 2/5 mr squared or anything. I just have to leave it as I. And then this is going to be v squared over r squared. Okay. So what I need to do now is actually factor out my v squared. So I have 1/2 m plus 1/2 I, or let me rewrite this a little bit. Okay, so it's going to be I divided by 2r squared. Okay, v squared mgh. Okay, and so then I'll have to divide by all of that stuff. Okay, I can actually go ahead and multiply everything by 2. So I'll multiply this by 2, multiply this side by 2, and so this part will cancel out. Okay, and so I have 2 mgh divided by m plus I over r squared equals v squared. And then I'm going to go ahead and multiply the top and the bottom by r squared. Okay, so I'll have r squared here, and r squared will go here. So I'll have m r squared, and then this one will cancel out. Okay, and so then I'll have v, let's take the square root of this. So I'll have v equals 2 mgh r squared over m r squared plus I root. So for number 4, that would be E. So for number 4, the correct answer is just E.